Hi everyone, this is the example that we worked through in class yesterday. I am going to re-record my solutions to this problem. I feel like we're a bit scattered in class and some people made some mistakes, and I also made a mistake on the final part because I considered velocity rather than speed. So I'm going to run through this question again. I am in the maths office recording this, so it's possible that you'll hear some background noise as people walk in and out of the office. And I'll try not to make this video as long as the last one. So let's jump straight into it and get cracking. So the question is, a particle moves in a straight line. It starts from rest at an origin O, and its acceleration, a meters per second squared at time t seconds, is given by a equals 4 minus t. And we want to calculate the velocity of the particle when t equals 3, the displacement from O when it next comes to rest, the displacement from O when t equals 12, and the average speed during the first 12 seconds. So let's actually try and put some of this information together. It's moving in a straight line, so let's actually do a quick diagram. Here's my straight line, and we've got some position O, the origin. And we know that it starts from rest. So if it's starting from rest, that tells me that the velocity is equal to 0 when time equals 0. And it also starts at the origin, so let's change colours here. It starts at the origin, so we know the displacement equals 0 when t equals 0. And we've got a formula for the acceleration here. Okay, let's just highlight that. So that's going to be my starting point. And I'm asked to find the velocity. But let's just think about what's this, when we say we're moving in a straight line, what's actually going on? So here's my straight line. If it's moving in this straight line, it's either going to be going forwards or backwards along this plane. Now I've drawn that sort of off the line to sort of show you the idea of it moving forwards or backwards. But what we've got to remember is it's actually going in one direction. It's either going right or it's going left. Okay, now it doesn't tell me right or left, some questions do, but I'm going to assume that this is to the right and that's positive, and this one is to the left and that's negative. So if the displacement is negative, then that means it's on the left hand side of the origin. If its displacement is positive, then it's on the right hand side of the origin. Okay, also, let's just, while we're sort of thinking about what's going on here, we are talking about acceleration, velocity, and displacement. So let's quickly write them down. We've got displacement, velocity, and we've got acceleration. And if we want to go from acceleration to velocity, I need to anti-differentiate. And if I want to go from velocity to displacement, I also need to anti-differentiate. So in this question straight away, given that we're starting with acceleration and we're asking for velocity, we know that I'm going to be anti-differentiating. So you can get your head around that right at the beginning, then you won't accidentally work the wrong direction. Okay, so let's start working on this problem. Let's find the velocity first. And I'm going to change colours there, I don't like that grey. The little things that matter. Find the velocity, and to find the velocity I'm going to anti-differentiate the acceleration with respect to time. So to do that I need to find the antiderivative of 4 minus t with respect to time, and when I anti-differentiate that, so I'll just put velocity is equal to the antiderivative of that, keep my notation going, I get 4t minus half t squared plus c. Now in this case, we don't know what c is, we have to find out what c is. So this point here, you need to find out what c is. And to do that, I use the initial condition. And that initial condition we know about velocity is that the velocity is equal to 0 when the time equals 0. So we're going to substitute v and t equal to 0 into this equation to find out what c is. So sub in to find c. And you can probably, possibly have already done that in your head and worked out that c is going to be 0, but I'm going to show that step anyway, because then I've clearly communicated all of my working out. And I get c equals 0. So now I'm going to write, therefore, my equation for velocity is equal to 4t minus a half t squared. All right, let's quickly go back to the question. What was it asking me to do? It asked me to find the velocity of the particle when t equals 3. So now at t equals 3, I need to sub that in. We get velocity equals 4 times 3 minus a half 3 squared, which is 12 minus 9 halves, which is 24 on 2 minus 9 on 2, which equals 15 on 2, or 7.5, and I think we're in centimetres in this question, weren't we? No, metres per second. Metres per second. Okay, that's part A done. Let's have a look at part B now. Part B says the displacement from O when it next comes to rest. Now this idea of when does it come to rest, that is really interesting. So it is at rest when the velocity equals 0. So the first thing I'm going to do in this question is I'm going to find out when the velocity is 0. So at rest, let's write that again, at rest when velocity equals 0, find when v equals 4t minus a half t squared equals 0. Sweet, so there's my working out. I want to find out when 4t minus a half t squared equals 0, and what you should notice is we have a null. So I'm going to try and solve this using the null factor law. That's the little reminder that goes in my head. First thing I'm going to do is take out a common factor of t. And then from that, either t equals 0. And we already knew that because we knew it was at rest at the beginning. So the velocity was 0 at t equals 0. And, sorry, not and, I should say, or 4 minus a half t equals 0. Solve that equation. 4 equals a half t. T equals 8. So here's my other point, or the second point. The second point when the velocity equals 0. And my question wanted me to find out the displacement when it's next at rest. So what that's actually asking me when I put those two bits together is I'm trying to find the displacement when t equals 8. Where did the t equals 8 come from? It comes from that point when it's at rest. Okay, so how do I find displacement? I'm going to use x for displacement, and it's equal to the integral of velocity with respect to time. And we know that the velocity equation was 4t minus a half t squared, anti-differentiating with respect to time. So displacement is equal to 2t squared minus 1/6 t cubed, and again, plus c. And we need to find c by substituting the initial condition. And in this case, because we're talking about position, the initial condition is displacement x equals 0 when t equals 0. So we're going to substitute those values in to find out what c is. And again, you might have done that in your head already, but I'm just going to show the working out here. Substituting 0 for x, I substitute in 0 for t, and I get 0 equals 0 minus 0 plus c. C equals 0. Therefore, my displacement equation is 2t squared minus 1/6 t cubed. And we want to find out that displacement at t equals 8. Alright, so at t equals 8, we get 2 times 8 squared minus 1/6 times 8 cubed, which is 2 times 64 minus 1/6 times 8 cubed. That's 64 times 8. 64 times 8. 2, 3, 8 and 6 is 48, so it's 512, which equals 128 minus 512 on 6, which is 128 minus, now I know they can both be halved, so that's 256 on 3. 128 times 3 is 4, 2. 3 times 2 is 6, plus 2 is 8. 384, so we've got 384 on 3 minus 256 on 3. A little bit annoying with these fractions, but we can do this. 384 subtract 256, 70 is 128 on 3. Hopefully I did that correctly. Probably worth checking with your calculator. But no, I reckon that's pretty good. 42 2/3. Quite sure that was the answer. Okay, so let's actually move into part C now. Most people did this pretty quickly. We want to find the displacement when t equals 12. It's the same idea, except now I'm going to substitute in 12. So I want to find x at t equals 12. So x equals 2 times 12 squared minus 1/6 12 cubed. And this time, just to speed it up, I am going to break out a calculator. Just finding my calculator here. So 2 times 12 squared minus 12 cubed divided by 3. Oh, that didn't work. Let's do that again. Said I was going to make the video short for you, and I'm taking ages. Alright, so we had 2 times 12 squared minus 1/6 12 to the power of 3, which is 0. Okay, and that's the answer that I was after. So x equals 0. So let's actually stop and think about what we've just done here. We know after 12 seconds, so at 12 seconds, displacement equals 0. We know that at 8 seconds, the velocity is 0. And the displacement is 42 2/3. And we also know that at 3 seconds, velocity is 7.5 meters per second, or positive. So if I want to go back to my graph here, so what's actually happening, we are moving through this point We start at O, and my acceleration is equal to 4 minus t. So when t equals 0, the acceleration equals 4. So I'm moving positive, so I start by moving this direction, and my velocity is positive. And we get to a point at 8 seconds where my velocity is now going to be 0. Okay, and my velocity is 0. That means that I'm actually turning around and going back again. And I go back so that my displacement at 12 seconds is back to the origin. And I also know that at 8 seconds, my displacement was 42 2/3 meters. So that's thinking about it on the line. We can also look at that on my displacement graph. So if I know the equation of displacement is equal to 2t squared minus 1/6 t cubed, I could find the x-intercepts by making y equal 0. Then I get, now I'm talking about x and y here, so that's probably a little bit wrong. I should say the t-intercepts is when x equals 0. So 2t squared minus 1/6 t cubed, common factor of t squared, and we get, trying to operate this here, 2 minus 1/6 t. So then t equals 0, or 2 minus 1/6 t equals 0. So t equals, or 1/6 t equals -2, t equals positive 12. So if I put those bits together, we've got the graph on the straight line above, but we can also do my displacement graph, x and t. It was a cubic, it was a negative cubic, and it has intercepts at 0 and 12, and this 0 come from the squared part, so that's also a turning point. My graph looks like this. Well, that's 12, that's 0, and we know the maximum would be at 8 when the velocity was 0. So that's my displacement graph. This is going to be important to understand for when we try and do the last question. Part D, I initially said, what's the average velocity? So this wasn't the question, but this is what I did in class. The average velocity is equal to the average rate of change of displacement. And the way that we did that is we found out the displacement at 0 and the displacement at 12. The question asks, I should have actually mentioned that. The question asks for the average speed in the first 12 seconds. So if I want to talk about the average velocity, now not speed, I know the question was speed, but if I want to talk about the average velocity in the first 12 seconds, then I find out the velocity at 0. I find out the position at 0. I find the position at 12 seconds. I join them with a secant, or I join them with a straight line, and then I find the gradient. So I find the displacement at 0. I find the displacement at 12. I join them with a straight line, and then find the gradient. Now, that we can see up here, that line is just a straight line. It's horizontal, so the gradient, in this case, is equal to 0. So the average velocity is equal to 0. But that's not the average speed. So the average speed is equal to the distance travelled divided by time. Now the distance travelled is slightly different. We know it's displacement at its displacement at time 0 is 0, and the displacement at 12 seconds is also 0. But that's not the distance. The distance is how far it's travelled. Now this object has gone up to a maximum of 42 2/3 metres. So the distance that it has travelled in the positive direction is 42 2/3 metres, and the distance that it's travelled in the negative direction is another 42 2/3 metres. So the total distance that the object has travelled is 42 2/3 plus 42 2/3 metres, or 42 2/3 times 2, and it's done that over a time of 12 seconds. So the average distance, so the distance travelled, go back a step, I'm confusing myself. To find the average speed, I need the distance travelled divided by the time. And my distance travelled is not the same as displacement. The distance travelled here is 85 1/3 divided by 12. So do that on my calculator. 85 plus 1/3, all divided by 12. And we get 64 on 9. So my average speed is 64 on 9 metres per second. So my average velocity was 0, but average speed, we have to consider distance. Distance is not displacement. So be very careful when reading the